Hello, I'm Norbert again, engineer and presenting video number 2 about heat pumps. Thank you all for the constructive feedback on the first version of this video. I decided to make a new one. Yes, in YouTube I am new, but not in energy. Already 32 years in sustainable energy, and that means renewable energy and energy efficiency. Heat pumps are present in many applications and sizes, also in your home. Especially dehumidifiers and mobile air conditioners are also heat pumps. And contrary to the split air conditioners and heat pumps, which have to be installed separately on internal and external sides of a wall, these smaller heat pumps are ready to run right after opening the box. That means reasonably easy to work on it. They also have a modest size and consumption. You can save a lot of money if you are willing to buy it second-hand and modify for your own means. Adaptation will make you independent from what is available on the market. Now let's see today's project. In this scheme here you see what I wanted to do. Just bring heat from outside to inside, even if it's colder outside. So it is like pushing a ball uphill against the tendency to roll downhill. In this video you see a dehumidifier transformed in a heat pump that takes only 150 watt electricity, but gives at least 400 watt heat. And that is where I use it for. So it lost its original function of air dryer. Yeah, and that's the power of the do-it-yourselfer. Okay, let's see what happens in this prototype. Here's the compressor in the middle, this black cylinder with copper pipes. On the right side you see the warm heat exchanger. It is called the condenser. I will explain that later. On the left side is a cold heat exchanger, the evaporator. Note that the one is in air and the other is in water. Before, when there was still a dehumidifier, both heat exchangers were in air. This change is also something that gives you decision power, because water can contain much more thermal energy. It is very dense in comparison with air, and you can more easily bring energy through a narrow hole, like here. Did you know that 1 liter of water has the same heat capacity as 3.5 cubic meter air? So, water will bring the energy more easily where you want, also through a wall. So, here's a cold evaporator that will subtract the heat from the water. Later I explain why this is possible. It goes through the thin copper pipes to the compressor that we saw already. Now let's think what will happen here with the water. You may worry that it will become a block of ice and then the game is over. So what we have to do is to bring this water outside through the hole and then onto the balcony, where the very cold water will warm up. You will wonder, how is it possible, because outside is colder than inside? The answer is that the water is now colder than the air outside. With antifreeze we can keep this water liquid even a bit under 0 degrees Celsius. So this very cold water will actually warm up outside, at least if we are not in Siberia or Alaska. This heat exchanger with computer fans will help the water to get the heat from the outside air. Then it goes back through the wall into the house and then into the bucket. Note that it enters the bucket at the other side of the heat exchanger compared to the water exit, where the water goes out of the bucket. This will create a water flow across the heat exchanger and ensure that it will not freeze. I made also some other water containers for the heat exchanger, which are more fancy, but they contain much less water, and I wanted to make the heat capacity of the container bigger, so I just took a whole bucket. Now here's the warm heat exchanger or condenser. It receives the heat from the hot gas coming from the compressor. This gas will come into the heat exchanger and meet the cold air from the house. The hot gas will condense and release the so-called condensing heat to the heat exchanger. This big computer fan here on 12 volt will suck cold air through the heat exchanger and push it into the room. You actually see here the entrance and the exit for the air. Now the fan consumes not much, but has an important effect. I observed, for example, that without the fan the evaporator got pretty cold but remains looking normal. Starting the fan and cooling the condenser, the compressor was able to get rid of the heat, so the evaporator very quickly became white with ice, and that was a good sign. It worked much better. Please be careful because you are working with high voltage and also with pressures up to about 20 atmosphere. Take glasses and gloves. When putting the cold and hot heat exchanger in a convenient position so that you can work with it, take care while bending the copper pipes. They have to keep a round cross section, and there is also the risk that the pipe will break away from the heat exchanger. Now let's try to understand how the heat pump is able to bring heat against the natural stream, which is from hot to cold, like a fish usually likes to go with the stream. A heat pump is much more like salmon swimming upstream in the river. If you already understand the heat pump, then you can easily skip this section, because my videos have sectors in the red YouTube timeline. So here you have a scheme of the heat pump. We start with the compressor that consumes your energy. It compresses a special gas that easily condenses when put under pressure. This condensation will release a lot of heat, so the hot heat exchanger is called condenser. It is the red heat exchanger in the figure. The liquid goes to the expansion valve and passes through a narrow hole into the low pressure area. This area is at a low pressure because it's from the one side it's on the suction side of the compressor, and on the other side it is separated from the high pressure by this narrow passage. So this low pressure will allow the liquid to evaporate and absorb heat in the same way as alcohol on your hand feels cold. So this part is cold, and it's called the evaporator. See the blue heat exchanger in the figure. Okay, now it's really time to stop this video. I have still to tell you the exciting things of this flexible technology, but we'll do that next week. You will learn how to apply heat pumps in unexpected ways that you don't find in the shops, but they are in your reach. Every example I propose is done by myself, or I will just tell you that it still has to be done. For example, I will tell you in the next video how I increased the efficiency in an incredible way by using both sides of the heat pump, and how to store heat and cold energy spending much less than with an electric battery. I hope you started to like heat pumps. In that case, you should begin to make plans to use them. Start by seeing if there are second-hand humidifiers or mobile air conditioners. Many people want to get rid of them. Unfortunately, they don't know that you can use an air conditioner or a dehumidifier for heating. If you have questions, please leave them in the space below. I hope that you will feed my personal energy to continue this new channel by sharing this video with people that need it or are just looking to have profitable fun. Please subscribe to be sure you won't miss my future exciting projects, especially next week, where I will show you what can be done concretely with the heat pump. I will be here for you next week. Have a good time. Bye.